Asistencia, gracias a todos los que estáis aquí en el aula, gracias a los que estáis en casa, en la oficina, conectados online. Y pues dentro del programa de profesores visitantes que tiene la Escuela de Caminos de la Universidad de Cantabria, hoy nos toca presentar a Jorge de Brito, que es catedrático de la Universidad de Lisboa, pertenece al equipo del Instituto Superior Técnico de esa misma universidad. Ahora mismo incluso es director del Departamento de Ingeniería Civil y bueno, es uno de los investigadores más citados y prolíficos del panorama actual. Su línea de investigación principal es el hormigón reciclado y pues ahora mismo presenta un índice H superior a 90, que es prácticamente un récord. Ha publicado más de 600 artículos EASY, artículos Journal Citation Report. Y bueno, pues sus áreas de investigación no solamente se centran en el hormigón reciclado, sino también pues en general la construcción sostenible, materiales ecoeficientes, predicción de la vida útil, sistemas de gestión de infraestructura y análisis del ciclo de vida. Y hoy tenemos la gran suerte de que pueda presentarnos esta conferencia titulada Recycle Aggregate Concrete, How to Close the Loop, cómo cerrar el ciclo. Sin más, muchísimas gracias, Jorge, en nombre de toda la escuela, en nombre de todos los alumnos, de los investigadores, también por las conferencias que nos estás impartiendo a título individual a los investigadores, estudiantes y profesores. Y sin más, te cedo la palabra. Muchísimas gracias por estar aquí. Cuando quieras, Jorge.
Gracias. Buenas tardes. Yo voy a hablar en inglés, si nos importa, porque es la lengua internacional de la investigación. Y si tiene alguna duda, me digan, porque yo intento hablar un poco en portuñol para vosotros, ¿ok? Okay. I'd like to start by thanking the University of Cantabria for the invitation, and especially my friend Professor Carlos Thomas for being here. It's always a pleasure to be in Santander and to meet some familiar faces. I hope that this presentation can be of some interest to you. The presentation is called Recycle Aggregate Concrete, How to Close the Loop. I'm going to take the opportunity to make a comment about the presentation of Professor Thomas. I don't like calling this type of concrete recycled concrete, because recycled concrete is something else. Okay, so recycled concrete is the actual recycled aggregates that are made from crushing pieces of concrete, elements of concrete. So I prefer to mention recycled aggregate concrete, because that's what we are recycling. Okay, there are other ways of recycling materials in concrete, namely the use of alternative binders, ligantes. Okay, so we can always use and should use other materials that we can put in concrete that, by the way, would probably have a much higher impact in the reduction of the environmental impacts than recycled aggregate concrete. Okay, so just as a way of presenting this idea, recycled aggregate concrete is definitely a good idea. However, it's not going to make a huge difference, neither in terms of costs nor in terms of environmental impacts. Okay, so I'm not selling very well the idea, but we need to be honest about what we are doing. Okay, so from what I know, costs can be reduced, okay, significantly reduced, depending very much on the market of the aggregates in a place where we are using recycled aggregates. Example, if we are doing this in Denmark or Netherlands, okay, where they have no quarries, where they can get the stone, okay, using recycled aggregates is not only good, it's a necessity. They need to do it. It's interesting, the example of Belgium is, we all know about that. Belgium is two countries. So we have southern Belgium, which is called Wallonia, okay? And Wallonia speaks French, and furthermore has mountains and has stone, lots of stone. So recycled aggregate in Wallonia doesn't work. Okay? On the other hand, we have Flanders, which is the northern part of Belgium, which speaks Dutch, okay, Flemish, and because they do not have quarries, they do not have mountains, okay, they have applied recycled aggregates for a long time, and their management of construction and demolition waste is very efficient because they really need to use that resource because they don't have coarse natural aggregate. Okay, so a lot depends on the local market in order to make this idea work. Another issue is the environmental impacts. The environmental impacts are very much dependent, from what I have studied, on the transport distances. Okay? So if we can minimize the transport distances involved in getting the aggregates to the place where they are building the building, okay, then we can have great advantages in recycling. However, the normal situation nowadays, both in Spain and in Portugal, is that we have a building that is being demolished. We have to take that waste for a long distance to a recycling plant, okay, long distance. Then we have to take that material to the premixed plant, the premixed concrete plant, okay, para hacer el hormigón, okay, and then we have to take that concrete to the working place. And so because of this, of all of these transportations, from an environmental point of view, recycled aggregate concrete can even be more impacting than normal concrete. Okay? So if people tell you that recycled aggregate concrete is always better from an environmental point of view, it is not true. Okay? It depends. Okay? But the general trend is that it is more sustainable than normal concrete. Okay? So moving on, let's talk about something that is very nasty, which is the CO2 production and CO2 emissions around the world. Now, we see there that we have several sources of CO2. We have coal. I'll show you some pictures next. We have gas and oil that are causing CO2 emissions. But we have there cement, and cement is responsible for 6 to 8% of all human emissions of CO2. And that is a lot. Okay? By the way, cement is the main reason why concrete has high environmental impacts. Okay, and just to confuse you, concrete has low environmental impacts. Okay? Compared to what? That's the issue. Compared to the alternatives. So we are using concrete for such purposes as structures in which the alternative materials have even higher environmental impacts. So when people tell you that concrete is the source of all evil, okay, is the great Satan, as I once said in a conference in Portugal. The conference was Concrete, the Great Satan. Is it true or something like that? So it is not true. Concrete has a huge impact on the environment because we build a lot and because we build almost everything in terms of structure in concrete. And why do people build almost everything they do in terms of structure in concrete? Because they are very stupid, because they hate the environment, because it's a stupid solution from an economical point of view? No to all of these questions. Okay? Concrete is the most used structural material because it's the best from all of these points of view, including the environment. Okay? However, do we have a duty to do something about the environmental impacts of concrete? Of course we do. Okay? So I'm trying to, give you the correct perspective about this issue. So what did I do? Okay. This should give some images of the coal industry, the gas, the oil, and all of these. This is a plant that is producing lots of CO2. Okay, but I think I believe I put everything into perspective, so we understand that even though concrete has very high CO2 emissions and that we need to control those, concrete, we cannot eliminate this, okay? There is only one way of eliminating the environmental impacts of many of the human activities, is for the whole population to die. None of us is interested in that solution, okay? So we all want to live. We want to have a decent life, okay? By the way, the Africans, the Chinese, the Indians also want a decent life. Don't forget about that, okay? So because of all of that, we are going still to have environmental impacts. Our duty as scientists is to try to reduce it to the minimum, okay? But anything that goes, we are going to eliminate environmental impacts, it's not possible, okay? Not with what we know at the moment. Okay, so because of that, and because in all of these underdeveloped countries, they are trying to get to the level that we have in Europe, for example, the average cement production is as expected to keep on increasing. It is very interesting if we analyze this graph. Look at Europe, okay? So Europe is, where is it? Here and there, okay? So it's these two, okay? It's these two. Look at Europe, okay? It's more or less constant, okay? So Europe is already making its impact, and it's not going to reduce. It may reduce, okay, but it's not likely to increase. Why? Because in Europe we are now moving mostly towards rehabilitation and not towards new construction. We already have all the bridges that we need. We already have all the roads that we need, okay, generally. Okay, so we are now on a different path to, say, India. Okay, let's look at this. This is China. And as you can see, China was, when this estimation was made, was still growing, but then it tends to grow. What does that mean? It means China is becoming rich. Okay? But you can see here other countries from India here, and Africa and the Middle East that are still increasing, and that percentage is going to increase. Now, so the bad news are we are going to have more cement production, much more than we do now. So those environmental impacts are going to increase, not decrease. Okay? Another piece of bad news is this. This was the estimated cement production in 2014. And as you can see, these estimations that were made around here failed, and the real cement production is going to be higher than the worst predictions here. So we are expecting to produce even more cement than before, and then all predictions, okay, unless we do something about cement. And that's why I mentioned the possibility, which I'm not going to talk about here, the mention of replacing cement with binders, ligantes, that have a lower environmental impact. Okay, and that's something we have to think about. But going back to aggregates, again, we see here similar trends. Okay, so again, this was a prediction. Okay, and as you can see, the production of the necessities of aggregates, okay, are going to increase over time, with most of the bulk not coming from Western Europe, which is more or less stabilized, but mostly from China. Africa is in here. It's going to also grow. Okay, so this is something that we have to again understand, that it's going to increase. Okay, so even though the aggregates in terms of the environmental impacts and even the costs of concrete are relatively minor, okay, they are still very big. Okay, so we also need to do something about that, and that's what I'm going to talk about. Now, another issue in which I'm going to concentrate a lot during this presentation is the issue of the construction and demolition waste. Everybody knows what construction and demolition waste is, okay? And what most people don't know is how important it is, okay? Why? Because we keep getting lots of information about other types of waste, okay, which are much more polluting than construction and demolition waste, and therefore get more attention. However, as you can see, the highest percentage of all wastes comes from construction and demolition activities. 34% of all waste produced by humanity. And furthermore, the mining and quarrying activities, quarrying as las pedreras, canteras, are responsible for another 27% of the waste. So construction is really responsible for a lot of waste. Okay? And should we use this waste to reduce the consumption of natural aggregates? Of course. Okay? Are we doing that? Well, no. That's what this conference is about. We are not doing that. We are not using in an effective way the huge amount of construction demolition waste that is being produced to reduce the necessity of using quarries. Have you ever been close to a quarry? To a cantera? It's not a pleasant place. Lots of noise, explosions, dust. Everything is polluted with dust all around the trees. You can't see the trees. It seems like snow has fallen. Okay? And all of that are bad impacts. Now, that's part of the problem. That's part of the problem, and that's part of the reasons why we should use more construction demolition waste. However, the fact is, most of the construction demolition waste, or almost all of the construction demolition waste that is being used, is used for bulk fills, to fill areas that have been excavated, and also as base and sub-base layers. But really, most of the material goes to places like this, or to the sides of the road. Okay? So we are not only, I'm not talking about this case. This case is a crime. Okay? What we are doing there is a crime. But this is not a crime, but it's what is called downcycling. Okay. I need to explain this. Recycling has three ways. Okay? Downcycling, which is that, is using a material, recycling or reusing a material to an extent that is below its potential. Do you understand? Well, it's like using beef to make beans with meat. Okay? The best meat for beans and meat is not, meat with fat, okay, which is cheaper. Okay? It's a bit stupid to use beef in beans with meat. Okay? So, now, recycling is using beef to make beef. Okay? Upcycling is to use, for example, a byproduct to use as a binder. Okay? That's upcycling. We do it every day with fly ash. Okay? Fly ash, we are not recycling fly ash, we are upcycling fly ash. Are you getting this? Yeah? Okay. Then let's move on. I am now going to brag is talk about what we have done. So this is the research center in which I work. It's called CERIS. Okay, CERIS is the biggest research center of civil engineering in Portugal. It's in at our department. Okay, the Department of Civil Engineering, Architecture and Georesources at IST, and IST, Instituto Superior Técnico, is in the faculty of Lisbon. Okay, and again, the faculty is the biggest in the university, and the university is the biggest in Portugal, the biggest and the highest ranked as well. Okay, and CERIS is a broad scope research unit, which means that we have hydraulics, we have geotechnics, we have construction, we have structures, we have systems, we have roads, we have urbanism. Okay, all of that is inside the research center. Okay, and so what I'm going to present is just a small part of what we are doing at this research center. Okay, we have cooperation with several other universities, and we now have two poles, one from Nova University that are now in CERIS, all from civil engineering, and another one coming from the people connected with the University of Coimbra, which is in the middle of Portugal. So we are a big hub, okay? And within this big hub, I'm going to tell you about some studies that we have done that concern construction and demolition waste, and therefore, indirectly or directly, concerns recycled aggregate concrete. Okay? So these are some of the studies that have been done in the past concerning waste management. Okay? So, for example, this one, we have analyzed, this is years ago, we need to update this study, but we analyzed all legislation that existed at the time in terms of allowing the use of recycled aggregates in concrete and mortars, okay? And we produced an analysis of all of this legislation, how good it was, how it compared, which one allowed more freedom, etc. Now, then we did a couple of studies of life cycle assessment. I must explain what life cycle assessment is. Life cycle assessment is a methodology that allows us to understand whether something has more impacts or less impacts over something else, okay, along a given period. Normally, we call it life cycle, okay? So, what we do is we analyze the number of different environmental impacts, and typically the conclusions are material A or process A has greater impacts in this category and lower impacts on this other category. So many people, namely politicians, namely the public, want very clear conclusions like, is material A better than material B? The scientists do not use expressions such as better, okay? Better does not mean anything, okay? We have higher means something, better means nothing, okay? So we can say that in terms of environmental impact, X, this material has higher impact than this one. In terms of environmental impact, Z, it's the other way around. And that's what we do, okay? And then politicians or whoever decide what to do. So we did that to compare recycled aggregates with natural aggregates, and also to compare recycled aggregate concrete with natural aggregate concrete. Then we did this, which was a characterization and quantification of recycling processes. We looked at many recycling plants, okay, and we made a comparison of methods, of the output, of the energy, of the actual quality of the materials they provided, and we did that for a number of recycling plants in Portugal. We also did this study, which was a very interesting study. I think I have a couple of figures from that study, which was a study of the viability. Do you understand viability? Well, it's almost the same in Spanish, okay? So it's the viability of building a construction and demolition waste recycling plant in the area near Lisbon. So we concluded what was the best spot, and then we made an economic viability analysis and an environmental viability analysis, okay? And we concluded that if we could put the recycling plant at full power, it would be a great idea in terms of costs, because it would pay off in 3 to 5 years, okay, the whole investment, and in terms of environmental impacts, it would be very good, okay? It was never done, okay? It was never done. It was just, it stayed in paper and never went wrong. Then we also did, this is not in chronological order, okay? So these studies, I have not been describing them in chronological order. We did a study that I have not seen nor before nor after, which was a study in which we built construction demolition waste indicators. For what? For different types of construction, residential, residential office, and what was the other? I can't remember now. We also did rehabilitation, demolition, and construction, different, and we also analyzed, for example, whether the constructions were made of concrete, timber is madera, timber, stone, etc. Okay, and we provided indicators. And much more, something that I have never seen before or after, we provided an appraisal of how reliable those numbers were. So when we had a big scatter, you understand, a great dispersion, okay, we said we do not trust these results much, okay? And we provided this information in a paper that has been cited very many times. Okay, so then the main area in which we worked was this, as Professor Carlos Thomas said. We did lots of works in recycled aggregate concrete. Recycled aggregate concrete is not only concrete made from crushing concrete. This, of course, is the best solution, okay? But in practical terms, we rarely, unless we use the waste from a recycling precast concrete plant, okay? You understand? Prefabricación. In outside those places, normally concrete is not separated from the others. So most of the time we have these mixed recycled aggregates. Okay? We can also have separated masonry aggregates from bricks or from tiles. Okay? And we did that as well. And we also did other materials. Some of them are obviously not the most adequate, okay, such as plastic and rubber. The results are interesting, okay, the results are interesting. For example, rubber, it looks as if it will not work. However, it can provide some properties, some interesting properties in terms of the ductility. In seismic areas, it could be interesting because the rubber functions in such a way that it accumulates some of the energy from vibrations. Okay, so it could be interesting. Glass is an excellent material for concrete. Okay, if we take into account the alkali-silica reaction. Do you know what the alkali-silica reaction is? So it's a reaction, a chemical reaction, in which the alkali in cement, they interact, they react with the silica from the glass, and what happens is there is an expansion, and the silica turns into gel. So it's not very good for concrete. Okay? It cracks concrete and also makes it weaker. Okay? So as long as we have some care with that, it's a good solution. And finally, we did an interesting study that I'm not going to present this time, Carlos, which was about using waste from the marble industry. Actually, we used all wastes from the marble industry. We used the coarse aggregates that result from broken pieces of marble that are not used. We used the fine aggregates as well, and we used something which was the sludge. So when cutting the stone, the dust becomes mixed with water, and they have these huge mountains of white dust, okay, which are not used for anything. And we investigated that, and all of these materials are viable to make concrete. Okay. Now, from this research, I'm going to highlight here a couple of cases. So what we did is we more or less understood that we could typify, we could have specific types of recycled aggregates. And the ones that were more interesting, because they are inert, okay, the ones that were more interesting come always in one of these groups, okay? So there may be beneficiation treatments necessary. Let me put here a parenthesis. If I'm not for specific treatments of CDW, okay? Because in most cases, the impacts and the costs of those treatments result in the fact that it is no longer interesting to recycle the aggregate. Do you understand? So if we are going to use recycled aggregates and we have to pay extra costs for that, maybe it's not a good idea. You understand? If we have to put environmental impacts because of, for example, chemical treatments, maybe not a good idea. Especially because afterwards we expect recycled aggregate concrete to have worse properties than the natural aggregate concrete. Okay, I'll see if I can talk about that later on. Anyway, we decided that there would be, this is the main recycled aggregate types there are, and then we came up with an idea. And the idea was this, it's in this graph. Can we forget about today's ways of using the recycled aggregates, which is mostly based on classifications such as these? Can we forget about that and start using the recycled aggregates regardless of its source? I don't want to know what the source is. I am worried about the properties of the recycled aggregate. And we chose two properties, which is the density and the water absorption. And we came to the conclusion that there was an excellent correlation between these two properties. And this is the line of correlation. And we also understood that the best aggregates were here and the worst aggregates were here. So we decided to propose this classification to classify all recycled aggregates. Did I say all recycled aggregates? Sorry, wrong. All aggregates. In my opinion, we don't have to call the aggregates names. Do you understand this? This is a revolution. We don't have to say that the aggregates are recycled. Why do we need to say that? We just call them aggregates. And then we look at their properties here and we decide how good they are. Of course, natural aggregates are mostly here, but not necessarily. We are using now natural aggregates that are over there. And no one is complaining. And many of the recycled concrete aggregates are here. Or there. Okay, there. Okay, depending on the... So, this is like, we do not need to know the source of the aggregates. We need to know their properties. Okay? This paper now has over 700 citations in Google Scholar, so it probably is not too bad. Okay. We also concluded from that study of the Portuguese construction demolition waste recycling plants that technologically, there is no reason why we can't use those. Okay? But of course, and we always need to think in those terms, the worse the recycled aggregate is, the less quantity we can use it. Right? Does this make sense? Do you understand? So the worse the recycled aggregate is, the lower the replacement ratio can be. Because it's all a matter not of the recycled aggregate that we put in, but of the resulting aggregate, which has natural and recycled aggregate. So this one is good, this one is good, we can put lots of it. And the mix is still good. This one is bad, the recycled aggregate, so we can only use a little bit. But it's stupid to say that we can't use any of it. Okay? Now, another taboo, do you understand taboo? Another taboo that we kept hearing is we can't do high strength concrete with recycled aggregates. He said, why? Why? And so we decided in one specific PhD thesis, which was made by someone who is getting married next Saturday, to make 100 megapascal concrete with 0 natural aggregates. Not bad. 100 megapascal, okay? 28-day compressive strength. 0 sand, 0 gravel. 0 grava, 0, como se diz? Arena, okay? None, 0. All 100%. Some of the regulations say that we cannot use not even one little bit of sand. We cannot use 1 grain of sand because it's going to, the whole thing is going to collapse. We used only recycled sand. Of course, what's the secret? This was made with recycled aggregate only of very high quality, taken from the precast concrete plant, and it worked. Am I saying here that we should use 100% recycled aggregate in bridges? No. It was simply an exercise to demonstrate that many of the things that people keep saying about recycled are not true. Okay, so this was just a demonstration result. This one was also a demonstration. This is João Pacheco, who is still working with me. Do you remember João, Carlos? Okay, now this was for his master's thesis. Then he did a PhD thesis, which is very, very good on reliability. And we built these structures, okay, and we did all types of tests with them. Materials, we did load tests, static, vertical load tests. We did static horizontal tests. We did characterization in situ, okay. We did all of those things, and finally, we decided to tear down those structures. And we did 4 structures, one with conventional concrete, one with 25% recycled aggregate, one with 100% recycled aggregate, coarse only, and then we did 100% recycled aggregate with superplasticizers. Okay? And our conclusion was that even though there were differences in terms of the properties of concrete, the structural behavior of the structures was very similar. Which of you has experience as structural concrete design? You have? Okay. Okay. So you all know, those that have designed concrete, you all know that concrete has a very small influence on, say, the flexure capacity of a beam. Okay? Whenever there is flexure, what really conditions the behavior of structural, reinforced structural concrete is the steel. Okay? As long as we keep the same steel, okay, the fact that concrete is slightly worse, okay, does not change the overall behavior much. And that is excellent news, because it means that we can use a relatively worse concrete and still get a good seismic behavior, seismic or whatever, big scale behavior, okay? And that's one of the conclusions of this work. Okay, so these are some research outputs of our team. Most of these is in recycled aggregate concrete, but some are also from recycled aggregate mortars, CDD management, and all the others that I have already presented. Okay. Now, mortars. Even though this is not about mortars, please allow me to tell you a little bit about mortars in which we have used recycled aggregates. We are now very much moving into other stuff. Okay, so this is fine recycled aggregates from concrete masonry and from CDW recycling plants. We investigated several issues about this, but now we are moving on to other, also these, plastic waste, crushed glass and ground rubber, all at the level of mostly replacing the sand, but we are also now working very much on several byproducts, okay, in which these byproducts, instead of replacing the aggregates, the sand, they are replacing the binder. And there we can have a great improvement in terms of environmental impact, even at the loss of some performance in terms of structural, in terms of mechanical behavior. Okay, again, my apologies. I like to introduce the subjects as they come to my mind. Most people think the environment is something that has only advantages. Saving the environment only has advantages. It's not so. Okay? In most situations, doing something that is less impacting in the environment is more costly. And it's a choice for us. We are the society. It's a choice for us to say we want to pay that cost. Okay? I could give you many examples of things in which what we are doing now is exactly that. We are paying more to have lower environmental impact. Almost always, the dirtiest ways of doing things is the cheapest. Almost always. Okay? Many of the things that you now take for granted were not granted 50 years ago. And in 50 years, I won't be here, but you will be thinking, oh, when I was 20-something, the things we did to the environment. Okay? So these perspectives change. What I want to tell you is this. Most of the time, the environment is a trade-off. So in terms of recycled aggregate concrete, you need to understand that by reducing the environmental impact, you normally get a reduction as well in terms of mechanical performance, which, as I demonstrated in the previous slide, is not necessarily important, but we need to keep that in mind. We cannot sell recycled aggregate concrete to people and say, oh, it's okay. There is no negative consequence of, no, it's not true, it's not honest. Okay? And that we need to send the right message. Okay? There is a cost to pay for recycling the aggregates in concrete. Okay. Now we're going to the most important part of this presentation, which is what I was mentioned at the beginning in the title, how to close the loop. Now, what do I mean by this? I don't know of any country in the world where recycled aggregate concrete is current. Is what most people do or what many people do. No, that does not exist. Okay? There is, to my knowledge, there is no country in the world where recycled aggregate concrete is used on a normal basis. So, you know, you go to an office and say, okay, design a recycled aggregate concrete building for me, please. And the guy says, okay, no problem. There you are. No, that does not exist. Okay? And the recycled aggregates so far represent only 8% of the aggregates, even in the best countries. Okay? And most of those 8%, almost all of those 8%, is not in concrete. Okay? So we are talking here about the future, not the present. And I'm going to talk about why the situation is as it is and what we can do to remove the barriers. Okay? So I'm going to give you barriers and then I'm going to talk about solutions. Okay? Please feel free to lift your hand and ask whatever question you need. Okay? So one of the barriers is this: inadequate segregation of waste at the source. Okay? Segregation is normally a bad word, okay? But here is what we need. Okay? If we do not segregate the materials, we only have mixed recycled aggregates, and their characteristics are worse. We cannot rely on them because they have not only a smaller characteristics, but also more variation in terms of characteristics. And that's the worst thing for designers and for concrete producers. Okay? Concrete producers do not mind knowing that they can use a material that is not so good, but it's consistently bad. Do you understand? So they know, oh, it's only 5 and it moves from 4 to 6. That's great. But if you tell them, oh, it's 10, but it can be from 5 to 30, they can't work with that. And that's the problem with the way we take care of the concession demolition waste. We go to a building, crash the building, the whole thing is over there, and then it looks something like this. Okay? And then what do we do with that? We send it to dumps, and we don't use it. So we need to separate, okay, and then have inerts, preferably concrete separated from masonry, okay, and then we have all the other materials all separated, okay. So what can we do about this, because this is common practice? Okay, we can implement what I called selective demolition. Do you know what selective demolition is? No? It's demolishing the building in such a way that you can separate the different materials and have different places where to put them, and then you can collect them and send them to the right places. So you have here a container with glass that you send to a glass recycling plant. You have another container with timber that you send for burning, and etc., etc., etc. Okay? So Selective demolition. Why don't we do it? Why aren't we doing more selective demolition? Well, many reasons. One, the most important one, is that it is more expensive. And it also takes more time to do it. So it's twice bad. It takes more time, and in the end, it's more expensive. But this is just part of the story. Why is it more expensive? Because people who do not do selective demolition, just crash down the building, they then can take this, which everybody knows cannot be used, and dump it at very low prices. What if there is, what if there is heavy taxes on people dumping? Okay, so you instead of dumping for €5 a ton, there came a law in which you were forced to pay €50 a ton. Then you start thinking, okay, I will separate, and then I will send it to the glass recycling plant, in which I get money. I don't pay, I receive money. Okay, I take it to somewhere where they sell very good aggregates. Maybe they give me a little money as well instead of paying. Okay, so when you put that all together, it starts paying off. Okay, it starts paying off, and that's without taking into account environmental impacts. If we converted environmental impacts into conventional costs, costs that we say, each ton of waste taken in costs the environment, and we make up a number, €20. And we say, if you want to do this, you have to pay €20. Then the whole thing changes. But we can do it in an even more drastic way. Okay? Like this. We can use our taxes properly. And we can tell people, look, if you're going to do selective demolition, and we are going to see if it is selective demolition, we give you incentives in terms of taxes, money that you pay to the government, your firm. You pay less taxes if you do this. It starts becoming interesting. Okay? We can also go in a different way, even harder way, which is what some countries are doing. In some countries, it is no longer possible to do non-selective demolition because it is forbidden to dump construction demolition waste. Forbidden. No, but I pay 100. No, you cannot. You cannot dump CDW. So imagine, you are demolishing a building, and you know that you cannot dump mixed construction demolition waste. You only have one option, which is to do selective demolition. Okay? It's again, society needs to make choices. Do we want to do this? Do we value the environment in such a way that we want to, because this will mean extra costs. Because you are demolishing the building and you are going to sell the building to him, okay? You're going to sell flats to him. You are going to pay for the selective demolition because you're the final user. And is society ready for that? We need to ask ourselves, okay? So let's move on. Please interrupt me because, Ignacio, you don't seem to be convinced. Denmark cannot, you cannot dump. Netherlands, same. And notice it's the places where they already recycle. Some of these guys are not, they are not more environmental than us. They have to be, and so they make as if they are very environmental, but they are not. The problem with you, you're Spanish, and with me, that I'm Portuguese, is something I'm going to talk about later on, which is natural aggregates are so cheap. The problem, did you understand? It's not good, it's the problem from this point of view. Okay, let's move on. This is a very important issue, insufficient supply and or demand. On the one hand, there are no people asking for recycled aggregates. You don't see, construction companies desperate to get recycled aggregates. Please give me recycled aggregates or sell me. No, you don't see that. Which makes it less likely that there are recycling plants offering recycled aggregates, good quality recycled aggregates. So this is a vicious circle. You don't have demand, you don't have supply, you don't have supply, you don't have demand. Okay? How do we break these? Well, let's go for the atomic bomb, the one I mentioned just now. Landfill ban. You cannot dump construction demolition waste. You think, wow, these people will complain. Will complain for 1 year, maybe 2 years, and then they get used to it. You remember what we said when the pandemic started? The things that we thought, this is impossible, we can't stay at home, we can't use masks, we can't. But in the end, we adapted. And that was for bad reasons. This is for good reasons. Okay? So if we stop landfilling, immediately we change the whole thing. Okay? We change the whole thing. We start having a need to make selective demolition. And then we have to have places where to take the separated materials. And then, next, we have other issues in which we can also change this situation from the point of view of the demand. I'm going to talk about that later on. Okay? Now, we could also, if we don't do the landfill ban, we could instead, softer, but we could customize the gate fees. Gate fees is what you pay when you dump. Okay? So, we can make it compulsory for the recycling plants to ask from their clients 100 euros per ton of mixed recycled aggregates, mixed construction demolition waste. They don't have a choice. They would like to take it for 20 euros or something, which is what they are doing now, but the state tells, no, you can't do that. Every ton that you receive, you need to demonstrate that you have received from the people 100 euros. Again, changes the whole perspective. We can have, and this is very important, at least in Portugal, strict control of CDW transport. Okay? We see many times, let's go back, we see many times these, okay? Near the roads, okay? Have you never seen these in Spain? Okay. So, what if someone who does that gets arrested and 6 months in prison? What if someone who does that pays 50,000 pounds, euros, I'm sorry? Will they keep on doing it? Okay? So you're saying it's too much. Well, sometimes to educate people, to educate children, you have to be a little bit strict. Okay? So you have to say, okay, you cannot do this. Oh, but I want to do it. Okay, you pay the price. Okay? So this is not science fiction. It has been done. Okay? Carlos here has roots from countries where things are strict, okay? And I don't believe these people are more law-abiding than us. I believe they have more fear. Because when they do it wrong, they really pay for it. Okay? Example. Steffi Graf's father. He dodged taxes. Do you know what you call a tax dodger? Do you understand tax dodger? People who try to avoid paying taxes, impuestos? Okay? What you call a tax dodger in Germany? A criminal. What you call tax dodger in Portugal? A hero. Okay? What if that hero goes to prison? No more heroes. Okay? Another thing that I already mentioned is the fact that the quarries of today can do incredible harm to the environment, to the people around, and they hardly pay any tax on that. And that is one of the reasons why, Ignacio, it's so cheap to buy gravel in Spain and in Portugal. Because there is no heavy taxation on extraction of natural aggregates, especially when that extraction has very bad consequences around. Okay? So, if instead of what happens today, in which we can get from a ton of, I'm not sure now if it is a ton or a cubic meter, no, it's a ton, 3 to 5 euros a ton we can get natural aggregates. Recycled aggregates, maybe half of that, or 2 euros or something. Is it worth trying? No. Okay? But what if the natural aggregates cost 20 euros a ton? It would make a difference. Okay? So, let's go on. Low quality of recycled aggregates. This is true. Okay? But it's truer, it's more true today than it can be. Why? Because the aggregates that we have look something like this. You can clearly see here bricks. Okay? Why is it like that? Well, because it's not worth separating at the moment. It's too expensive. Look, didn't I say that natural aggregates are sold for 3 to 5 euros a ton? How much can they ask for these if they want to sell it? Especially in a country where second-hand things are bad things by nature. It's in our culture. In the UK, no problem with second-hand. In Portugal, because we are much richer than the UK, you know that, we don't take second-hand. We don't use second-hand clothes. We don't use second-hand shoes. And especially, we do not use second-hand recycled aggregates. Okay? So, if you're going to sell these, you have to sell it for 2 euros a ton. Otherwise, no one is going to buy it. You cannot separate for 2 euros a ton. Right? Okay? So, let's now see. So, what we can do is improved triage. Triage is separation of input CDW. This, of course, is connected to many of the things I've said. Selective demolition, the fact that it needs to be economically feasible, okay? And, of course, the need to have the right equipment at the recycling plant to do this, okay? And sometimes at the demolition site, okay? So, improved separation is one thing. Comprehensive beneficiation processes. There are some processes that are not too expensive to do, but still they make a big improvement. For example, wind blowing and getting rid of plastic and other very light materials, it works. The magnets to get out, separate the metal materials. Okay, so there are some beneficiation processes that are cost effective. Okay, now this is another thing that I already mentioned: performance-based classification of recycled aggregates. Instead of calling the aggregates names, this is recycled aggregate. Recycled is a bad word. It does not sound good. You don't want something recycled, right? What if I don't tell you that it is recycled? What if I give you the properties of the materials? Okay? And by chance, 50% of what you're getting is recycled. But the important part is that you have the aggregates classified in terms of performance, not in terms of source. Okay? It's a little bit, I don't know if this is a good comparison, but it's a little bit like race. It's not relevant, the race that we have. What is relevant is what we do, how we perform. Okay? Here is the same thing. Okay? So we are advocating performance-based classification. Okay? And then there's certification, because this is the real problem of concrete producers. They have to have their materials certified. Okay? What if, by several of these measures that I mentioned here, the concrete producers need to have recycled aggregates? We'll talk about that later on. What if they need to have recycled aggregates in concrete? Then there is a market for recycled aggregates of a given quality, Jose, not any recycled aggregates, of a given quality. And then there's going to be people who have recycling plants that will make whatever is necessary to guarantee that their materials are certified and can be sold to the mixed producers, concrete mixed producers. Okay? So it's all connected. Okay? You need to give the right incentives. Now let's look at this from the perspective of the designers. I was a concrete designer for 15 years, and I know of very few people who are less conservative than the designers of structures. They would prefer to live in the Middle Age, not to change anything. From their point of view, if codes could stay forever the same, great. New materials, no way. Materials that we don't know about, no way. Okay? So their perspective is very, very... So I have lots of colleagues in my school. They tell me, look, George, I'm convinced that these materials can be used. Show me how I can use them without risk. That's what they have. And I tell them, what you consider risk? Oh, I know the scatter. They have a huge scatter of properties. Yes. And I ask, what about natural aggregates? No scatter. What do you mean no scatter? No scatter? Let me show you this. And then they have the nightmares. Okay? Because, for example, concrete made with sandstone, both of you have designed concrete structures, right? Did you know that concrete made with sandstone is natural, okay? Natural aggregate has 70% concrete, not the aggregate, 70% of the expected models of elasticity of a granite made concrete. Did you know this? No. Neither do my colleagues. They believe that natural aggregates are all the same. They have exactly the same properties. And by the way, the modulus of elasticity of C2530 is 32, I believe it's 32 gigapascal, not just 32, 32.1 million zeros. Exactly 32. And they work on that basis. Then when I tell you, no, it's 32 times 0.7 for average sandstone, average, not worse sandstone, okay? Average sandstone is 0.7 that value, and for average basalt is 1.2 that value. Oh, then it's not 1 million zeros after the 32? No, it's not even 30. Okay? It's not even 30. It is 20 something to 40 something. 40 no, but almost 40. Okay, so people do not know about this. But I understand them. So what can we do to take into account the fact that there is a lack of comprehensive standard specifications in legislation? For example, there you have the specification of National Laboratory of Civil Engineering, and two other documents, one from British Standards and the other from RILM. None of them are very helpful. Maybe the one that is more helpful is LENEC, but I'll make a comment about that. So we need to update existing specifications, namely those that do not consider the possibility of having recycled aggregates. There are many that don't have that possibility. Okay? We need to update those standards with the knowledge that we now have. And we need to change totally, and this is even more important if we are going to change the binder, and it is changing the binder will have a much larger impact on the impacts. Okay? If you're going to change the binder, all of the laws that we have do not apply. Do you understand? If you are going to use concrete in which 70% of the cement has been replaced with limestone and fly ash, which is already done, okay, then the properties are not the same. Furthermore, the compressive strength does not relate with the modulus elasticity in the same way. So we cannot just say, oh, the compressive strength, the strength class is this, so we know everything else. It does not work like that. Okay? So we need to change, and this is being done, by the way, to performance-based specifications. Okay? Now it's going to be allowed to have any type of composition as long as you try it and demonstrate that the properties are these, and then you can use these properties to make your design. It's not as simple as this, but this is the general idea. And of course, we need universal specifications for the use of recycled aggregate in concrete. What do I mean by universal? I mean that we do not have to call the aggregates names. As we stand right now, I can demonstrate that our specifications are wrong. Just for the simple fact that they do not consider the type of aggregate that we are using. And I'm talking about natural. Okay? There is a paper that we have published in which we question today's ways of defining the compressive strength of concrete. Okay? And the paper shows that the way we are, as you know, there are several methods of guessing the compressive strength through the composition, okay? And they fail by a lot if we change the aggregates. So they work more or less with a given type of aggregate, but if you change the aggregate, they fail by a lot. So we are making those compositions, and we are expecting to have 32, and we get 25, or we get 40. And none of this situation is good. Okay? So I'm hoping that we will have specifications in which there is some influence of the type of the aggregate, see you, Ignacio, on the properties. Okay? I see that people are leaving, so I'll have to accelerate a little bit. The lack of knowledge by stakeholders. I've already been talking about this. Many of the stakeholders, namely the designers, are very ignorant about materials they are using. Okay? So, what can we do about that? Well, to start with, we need to have green marketing. We need to convince the people that are going to use, the promoters, we need to convince them that it is good and they do not have big risks by using recycled aggregate concrete. Okay? Saying that they do not have big risks is not lying. That's not what I'm saying. It's explaining exactly what is happening. Okay? And there's no big difference between what we are doing at the moment and using recycled aggregate concrete. We need to increase the number of real scale applications. In Switzerland, they are already doing a relatively large number of real scale applications in which they are using recycled aggregates. Okay? And it seems, have you heard of many people dying from buildings falling in Switzerland? No. Okay? So it's okay. And then we need, and this is for us to do, to create specialized courses. We need to explain to people not only the new standards that are going to come up with ways of making it possible to use recycled aggregate concrete, but we also need to give education to those structural engineers that have been educated a long time ago so that they understand what they need to do to start using structural aggregate concrete. Okay, and this is, I believe, the end of these measures. Okay, not working. Okay, now this is simply a list of some research that, in my opinion, needs to be made. Okay, so we need to improve the quality control of the supply chain of aggregates. This is true also for natural aggregates, by the way. Okay, we need to improve this to have more confidence on the properties of the materials and the properties of the concrete. We have worked on this already. We need to have multi-criteria optimization of the use of concrete. Why? Because in the studies that we have done, the studies of Rawaz, Kurda, we came to the conclusion that if we analyze different types of concrete with different binders, with different with different aggregates, we came to the conclusion that some of the properties went up, some of the properties went down. Okay, so we need to have tools to say, okay, if the environment has been improved and the compressive strength has been decreased, which is better? Okay, so how do I go about this? By the way, I truly believe we will have weaker structures in the future. Not for bridges, okay, not for large-scale structures. For normal buildings, for houses, we have been guaranteeing durability at the cost of improving compressive strength. You all know about this because you know that near the sea you have to have a strength class very high. Why? To do a house, 1 story, and you need a C 45, 56, what's the one before? 40, what's the one before 50, 60? The class, the strength class before 50, 60 is? I can't remember now. So it's 37, 45, something like that. Okay, we need to have a very large, very strong concrete by the sea. Why? because it's the indirect way, because a strong concrete is also a less permeable concrete. This is true, Paulo. We are using very strong concrete near the sea because that's the way to guarantee durability. And that is very stupid. This is very stupid because the concrete that you need to do has very high levels of cement, and you are only doing that to block the passage of chlorides to concrete. We need to find a more efficient way than totally abusing the environment by putting 500 kilograms of cement. That's stupid, okay? So we need to do that, okay? And that's what I mean by that. Then, the shrinkage and creep of recycled aggregate concrete are one of the weak points of recycled aggregate concrete. We need to know more about this. It's one of the weak points. We are working on this as well. The structural behavior, sorry. The structural behavior and reliability of structures made of recycled aggregate concrete. João Pacheco is working on this. And we have worked together with Professor Carlos Thomas also on the multi-recycled aggregate concrete. Why do we need that? Because the future is not just tomorrow. The future is in 100 years. Why don't we recycle concrete indefinitely? Do you understand what I mean? So we already have all the houses that we need. I hope that the world population does not keep on increasing. Okay? So let's suppose that the world population stabilizes. We create housing for all of these people. From then on, we don't need to have more housing. We only need to replace housing. Why don't we use the concrete made from one house to make a new house for the same person? Does it make sense to you? Okay? So, we need to understand what happens when we recycle and recycle and recycle. By the way, unlike what most people think, if it were not for durability and for steel, not concrete, steel, our houses could be designed for 200 years, 300 years. Concrete, unless in very few situations, is almost eternal. We have concrete in Rome at the Pantheon, 2000 and something old, still there. Okay? What is the difference between that concrete and today's concrete? Well, different binders, okay, it's pozzolan concrete, but that's not the point. The point is there is no reinforcement. Okay? 95% of the problems of concrete structures have to do, durability problems have to do with steel. Okay? So, let's move on, because this is the last slide. Okay, this is the last slide, and it's a message. We can use recycled aggregates to make concrete. Okay? It is viable from a technological point of view. However, we need to do it in a way that it is also economically feasible, okay, and positive from an environmental point of view. Okay? And this results from an analysis of case to case and changing many societal conditions in order to start using the waste in a better way. What we cannot accept is that we keep on throwing away resources made of materials the way we do now. We have these huge quantities of construction demolition waste, and we use it, most of it, to landfill. It's not acceptable, okay? But as you saw, there are many things that need to be changed, and I'll give you an example that would work perfectly. The government, the local government of Cantabria only needs to tell road constructors, road designers, that 10% of the aggregates they use have to be recycled. It only needs to tell the construction companies and the promoters 5% of the aggregates, 5% of the aggregates must be recycled aggregates. And of course you have to demonstrate it. Okay? And in one day, all things would change. Because there would be a need for recycled aggregates that are in a demonstration that they are recycled. Okay? So recycling plants, the people who build it would ask the people from the recycling plant, look, I don't want any type of recycled aggregate. I want a certified type of recycled aggregate. So they would have to do something about that, okay? And suddenly there's a market. You are from the recycling plant, you need to tell the people who give you the CDW, look, I need this type of material. Or you have to do something about it in the recycling plant, which is probably more expensive for you. Okay, so that you can then give him, ready-mixed producer, concrete producer, the material, so that then he can give him, who is the constructor, the right concrete with at least 5% of recycled aggregates. And this whole thing changes. Okay, the whole thing changes. By the way, in the middle, somewhere there must be a designer that needs to understand and start designing concrete with 5%. With 5% recycled aggregates. Because that designer is going to say, look, I cannot ignore this, so I need to know a little bit. So he's going to start worrying about that. If he's going to start worrying about that, there's need for standards, etc., etc., etc. Okay? So, you know, a simple law, just like this, would immediately change things. Okay? Okay, that's all. Thank you very much. Sorry for the time I took. Thank you very much.
Thank you very much, Jorge. We have now short time to questions. If you have questions here, there are people here in the online version, and let me see if there are questions. Okay, no, here no questions. Here.
Yo puedo responder en portuñol si quiere. Sí, sí, si quiere.
¿Alguna pregunta?
No sé. Sí, sí, por favor.
Hola, hola. Mi pregunta va más relacionada a si hay alguna manera de no forzar desde la administración el uso de áridos reciclados, porque la mayoría de las medidas son pues con impuestos, con multas, obligando al constructor a utilizar esos áridos reciclables, ¿no? ¿Crees que en algún momento va a llegar a poder utilizarse esos áridos reciclados de motu propio por el constructor?
La sociedad va mudando. ¿Okay? Hoy en día hay mucha cosa que tú no vas a permitir, tu conciencia no permites, y eso va a cambiar, haces parte de la sociedad, puedes influenciarla, y hay leyes que siempre se van mudando. Te voy a dar un ejemplo. Todo lo que tiene que ver con el género, ¿okay? Están saliendo leyes que impiden algunas situaciones que no estaban correctas, tenían unas razones culturales, históricas, etc. Pero ahora la sociedad dice a las personas que hacen las leyes, esto no puede seguir. Bueno, yo no estoy viendo ahora las personas marchando para que para que haya más áridos reciclados, no. Todavía no estamos ahí, pero hay países en que sí, en que la conciencia ambiental es mucho mayor que aquí. Entonces, lo que yo he hablado, que es de green marketing, sí se puede hacer, y si las personas piensan que no es aceptable tener un basadero, donde se landfill, vertedero, pierto de tu casa y empiezas a marchar, el vertedero se va. Entonces hay que procurar soluciones para este vertedero y bueno, las cosas, muchas de ellas empiezan así. Una imagen verde funciona muy bien desde el punto de vista político. Por ejemplo, en Portugal, lo que han hecho con la energía, y yo pienso que ahora también se está haciendo en España, han acabado con las centrales térmicas. En mi opinión, demasiado deprisa, porque había un plan para hacerlo hasta 2025 y Portugal ha cortado en 2021. Y ahora tenemos problemas, porque ha sido demasiado brusco, porque algunas veces, sobre todo los políticos, no entienden lo que es bueno y lo que es ótimo. ¿Okay? Y entonces, reducir mucho el impacto ambiental de la energía a través de la forma de conseguirlo, es una cosa buena. Cortar totalmente la posibilidad de tener una energía que es más sucia, pero siempre está pronta, no dependemos de otros países como de Rusia actualmente, es otra. ¿Okay? Y algunas veces hay que ser un poco más pragmático y avanzar un poco más lentamente para conseguir las leyes, pero esta situación el gobierno portugués lo ha hecho, ha acabado con las centrales térmicas, porque en la opinión pública ese mensaje ya estaba. Para las personas, sí, bueno, toda la gente ha dicho muy bien, porque ahora no sabe nada, porque no hay estudios serios sobre el impacto y ciertamente las personas que apoyan eso no lo saben. Pero la percepción pública es esa. Entonces, en un país maravilloso que no existe, sí te daba razón. En un país no maravilloso que es este, no. Te podría dar muchos ejemplos de cosas que tú hoy piensas, bueno, no era siempre así y que han sido impuestas. ¿Ok? Muchas leyes, bueno, como se dice, las casas de baño, las bañeras. Sí, donde en tu casa, cuarto de baño. Los cuartos de baño no eran una cosa normal. Hace 100 años, 80 años. No era normal. Una persona pensaba que, bueno, eso es un poco excéntrico. Y no estoy hablando de personas pobres o en el campo, estoy hablando en la ciudad. Yo he vivido en un edificio que era de los años 20, centro de Lisboa, y al principio no tenía baño. Es muy claro que la zona donde están los baños en ese edificio es nueva, porque el edificio es todo de madera, estructura de madera, y en esa área han hecho losas de hormigón. Entonces no había. Había una cosa horrible, no sé cómo lo hacían, pero había una cosa horrible para dejar agua, pero no sólidos, ¿entiendes? Y eso era años 20 del siglo XIX, del siglo XX, años 20 del siglo XX, en la capital de un país. Hoy tú tienes que esforzado a tener baños en tu casa. Mesmo si tú no quieres te bañar, lo tienes que tener y tienes que pagarlo. Entonces, hay muchas cosas que las personas no entienden cómo se han cambiado, pero se va por esa manera. Hay partidos hoy que tienen una mensaje que es totalmente vaciada en el ambiente. No, las personas pueden votar en ellos o no, y cuando votan, eso tiene... Entonces, pero la mayoría de las veces el progreso no se hace porque el pueblo es iluminado. Se hace porque hay alguna persona que gobierna el pueblo que sí es iluminado y después lleva las cosas así. Infelizmente, muchas de estas medidas costan. ¿Ok? Costan. Entonces, tú no vas a ver las constructoras a hacerlo voluntariamente. No. ¿Ok? Porque las constructoras no tienen culpa de todo. Porque hoy en día, como en todo, como en muchas otras áreas, tú puedes comprar papayas de África, ¿cierto? Y quieres comprarlas baratas, ¿cierto? Bueno, no está cierto, porque las papayas que estás comprando de África tienen un impacto ambiental increíble. ¿Ok? Pero todavía tú las quieres, y baratas, ¿cierto? ¿Ok? Con la construcción es las mismas cosas. Tú esperas que tu municipalidad te haga un recinto deportivo con tus impuestos, y lo que la municipalidad va a hacer es practicar unos precios increíblemente bajos, y va a haber una constructora muchas constructoras que van a intentar hacerlo por esos precios muy bajos. Claramente la calidad es la principal víctima de este proceso. ¿No es? ¿Cierto? Cuando la política de precios en muchas áreas es lo más bajo posible, la calidad es la víctima en todas las áreas. Entonces, muchas de estas medidas son medidas en que tiene que haber una escoja societal. La sociedad como un todo tiene que escoger. Yo quiero hacer las cosas como se hacen ahora, más baratas, pero con más impacto ambiental, o quiero cambiar eso. Y eso es la razón porque casi todo lo que se ha hecho en términos de ambiente se ha hecho en los países ricos. Piensa en Amazonia. ¿Sabes lo que es Amazonia? ¿Tú piensas que los brasileños de Amazonia soportan las medidas ambientalistas? No. La mayor parte, claro. Los indios sí, porque no tienen un trabajo ligado a la industria, ¿ok? Pero la gente que está no es necesariamente rica. La gente que vive en Amazonia, que son los brasileños, no les gusta las limitaciones. Por ellos quemarían todo. ¿Ok? Es la sociedad en general, los gringos, que le dicen, no puedes quemar. ¿Ok? Es mucho así como las cosas acontecen. Y los gringos lo pueden hacer, sí, pero tiene que compensar de una manera, porque para estas personas, ellas son muy pobres, entonces ser ambientalista, imagínate en Mali, un país de África, bueno, estás muriendo de frío y hay una única árbol, que es la única. ¿La vas a quemar o no? Claro que vas. Entonces, hay que crear riqueza para tener ambiente. Las personas no entienden esto, pero es mucho así. Y conciencia.
Sabía que te veías joven, novo, pero no sabía que tanto, que en 1920 ya estabas viviendo en Lisboa.
No. He comprado una casa que era de esa altura, sí.
Hay unas preguntas en el chat
Sí.
online, te las planteo, son varias, pues las hago todas juntas para que las puedas responder. La primera... Disculpadme, voy a plantear una serie de preguntas que se nos han propuesto en el chat. Son de Jorge Aparicio y, bueno, en primer lugar te felicita por la conferencia, que ha estado muy bien, espectacular. Pregunta, la legislación portuguesa, a lo que hace referencia a la valorización de subproductos, residuos, ¿es estatal o autonómica? ¿Es de las comunidades o de todo el país? Otra pregunta que hace el mismo asistente es si se hicieron corpos de probetas con árido reciclado y natural para diferentes contenidos de cemento y si hay diferencias entre ellos.
No he entendido. Dos preguntas de cada vez. La segunda es...
La segunda es si hay diferencias entre las probetas, los corpos de prueba, los testigos realizados con diferentes cantidades de cemento y árido natural y árido reciclado.
Sí. Bueno, empezando por la segunda, claro que hay. Cuando se cambia la cantidad de cemento, se tiene diferentes características. Cuando se cambia el tipo de árido, dentro de los naturales o entre naturales y reciclados, hay consecuencias. Todo eso tiene consecuencias. Yo podía hablar de la especificación del Laboratorio Nacional de Ingeniería Civil, que tiene una forma totalmente diferente y errada de hacerlo, pero puede ser la manera de hacerlo. Lo que la especificación dice es lo siguiente: si nosotros usamos porcentajes de sustitución abajo de los límites que ellos dicen, de áridos con unas características que ellos hablan, ¿ok? Entonces el hormigón que he hecho con eso tiene exactamente las mismas características que el hormigón hecho con áridos naturales, que no es verdad, ¿ok? Esto no es verdad. Es una manera de hacer las cosas para simplificar muchísimo la vida de los proyectistas, pero está errado. ¿Okay? Entonces, esta es la segunda pregunta. La primera pregunta, yo no sé si Jorge Aparicio es portugués o castellano.
José Aparicio García, probablemente sea español.
Es español. Bueno, las autonomías en nuestro país no tienen la misma importancia que en España. Nosotros tenemos dos regiones autónomas, que son Madeira y Azores, pero estoy seguro que las leyes sobre esta materia se aplican en todo el país.
Más preguntas, también pregunta si se planea Portugal hacer mecenazgo de demolición selectiva utilizando el concepto de escala, es decir, planteando ahorro por mayor volumen reciclado.
No conozco el concepto, no hay hoy cualquier tipo de incentivo a la demolición selectiva. Lo que puede acontecer es que el promotor, los casos que yo conozco, es que el promotor lo ha promovido, ¿ok? En un caso ha habido un promotor muy famoso, que soy yo, que lo he promovido en mi casa cuando he hecho obras y he pagado una nota preta. He pagado una nota preta porque la demolición selectiva es mucho más cara, ¿ok? Mucho más cara. Pero, bueno, yo sentía que no podría ser de otra manera.
Otra pregunta también es si hay legislación europea acordada para la valorización en diferentes países de la Unión Europea.
Sí, claro, sí, hay y se está haciendo más. Y ahora mismo yo estoy haciendo un estudio para la Unión Europea, bueno, que no puedo hablar mucho de él, pero estamos levantando lo que se pasa en los diferentes países para compararlo y tener algunas conclusiones sobre eso.
¿Y si hay alguna restricción normativa a la hora de explotar los residuos?
¿Qué es explotar?
Explotar es utilizar.
¿Alguna norma europea?
Alguna restricción normativa. Si hay alguna norma, alguna ley estándar que impida o que regule, que limite...
Bueno, en cada país hay algunas, y yo he dado el ejemplo de la especificación LENEC para Portugal. En diferentes países hay diferentes reglas, pero todavía que yo conozca, no hay una regla europea de esto. Por ejemplo, una otra cosa que no me gusta en la especificación LENEC, pero también lo entiendo, es que prohíbe totalmente el uso el uso de arena reciclada en hormigón. Completamente prohibido, no se puede. Y sí se puede, pero hay que tener eso en cuenta porque la incorporación de árido reciclado fino es más dañosa que el grueso, pero bueno, hay que usar menos. Sí, se podría, pero hay que usar menos. Yo no comprendo una ley que me dice que no puede, pero comprendo que eso es una manera simple de facilitar el uso. Así las personas saben que no pueden utilizar arena y no hay que dar ninguna reglas sobre las consecuencias de usarla.
No hay más preguntas.
Okay.
Entonces, damos por finalizada la conferencia. Insisto en agradecerte, Jorge,
Gracias, Carlos.
que estés aquí, que hayas venido de Lisboa a Santander para esta conferencia. Muchísimas gracias.
Gracias, gracias. Hasta luego. Ok. ¿Ya está? ¿Cerramos? ¿Ya está? Ok, gracias, gracias a ti. Sí.